Hello everyone and welcome back. I am Mr. Cobalt and today we are going to go over our first problem using or referring to the average atomic mass. So in the last video I talked about how the average atomic mass is calculated and what that means. In the next couple of videos, I'm going to go over a couple of different problems. So this is the first problem. So this is a typical straightforward problem that's asking you to calculate the average atomic mass of a particular element. And they give you the isotopes and the percent abundances and the masses of the isotopes. So problem number one, copper has two naturally occurring isotopes, copper 63 with a mass of 62.9291 AMUs and a natural abundance of 69.17%. And copper 65 with a mass of 64.9278 AMUs and a natural abundance of 30.83%. Calculate the atomic mass of copper. And so what they mean is the average atomic mass. So if we go back to what we learned before regarding the formula, what we're going to do is we're going to find the fractional abundance of each isotope and multiply by the mass of each isotope and then add those together, and that will give us the average atomic mass, which is the atomic mass of copper. So they give us our first isotope is copper 63. They give us a mass of 62.9291 AMUs. So the atomic mass of copper is going to be equal to, I'm going to take the fractional abundance, which is 69.17, and I'm going to put that over 100, right? Because the fraction of a particular amount of atoms, and we can assume any amount we want, but since they gave us a percentage, we can assume out of 100. So out of 100, 69.17 atoms are going to have this mass here. So I'm going to multiply this number out of 100 by the mass, and that's going to give us the total mass for that number of atoms out of 100. So multiply that by the mass of this particular atom. So 62.9291. And that's, I should put AMUs. So we need our unit, AMUs. Okay. This is unitless. It's just a percentage over 100. So here we have our AMUs. And then here's our first isotope, and now we're going to add our second isotope. We're going to do the same thing. So copper 65 has a mass of 64.9278 AMUs, and it has a percent abundance of 30.83. So we're going to turn that into a fractional abundance by dividing by 100, because again, the fraction is out of 100. So 30.83 atoms out of 100 is going to be this isotope here with that mass. So we're going to multiply by this mass. So it's going to be 64.9278 AMU. And that's it. We only have two isotopes. So now all we have to do is multiply, divide, add these together, and we got our answer. So let's go ahead and do that. Let me get my calculator. Okay, so the answer would be, so I have, 69.17 divided by 100 equals, multiplied by 62.9291 equals, okay, and then, oops, I have an error. What happened? All right, let's try this again. 69.17 divided by 100 multiplied by 62.9291 equals. And then I'm going to add to that this. So there I have 30.83 divided by 100 multiplied by 64.9278 equals, and I get an atomic mass of, so this is going to be equal to 63.54, or if I round it, it's going to be 5. So let's say 5, 5, 4, 5. I'll stop there, and that's going to be AMUs. Okay. So then again, because this is a calculation, I have to pay attention to my sig figs. So I have 6 sig figs here, and here I have 4, and that's out of 100. That's an exact number. So I have 4 here, 6 here. So when I multiply and divide, my answer should only be 4 sig figs. Again, here, if I multiply and divide, and here I have 6 sig figs and I have 4, so I should have 4 sig figs here. That's going to get me to 2 decimal places on this. So if we do the calculations separately, let's do these separately so we see what I am doing. So I do 69.17 divided by 100 multiplied by 62.9291 equals, and so that gives me a 43. So this is going to be 43.528.528, and then there's more digits, but that's enough. And then I'm going to add to that this. So let's calculate what that is. So we have 30.83 divided by 100 multiplied by 64.9278 equals, and I get there 20.017 AMU. So AMU. Okay, so now you can see what I'm doing here. So when I multiplied and divided here, the rule, remember, is when you're multiplying and dividing, your answer can only be in the least number of sig figs as the number that has the least number. So the least number here is 4 sig figs. So that means I would cut it off here, and you'll see the 2 decimal places. Here, same thing, 4 and 6. So my answer should only have 4 sig figs. So I'm going to cut it off there. Now remember, for rounding purposes, I'm not going to cut it off and do rounding before I get to my final answer, because I still have to add these together. If I cut this off and round too early, then I'm probably getting a rounding error, and I don't want that. So I'm going to keep the extra digit and continue my calculation. So when I do my calculation, I'm going to add that plus 43.528 equals, and then I get my final answer. So I add those together and I get 63.5452 5452 AMU. Okay, so now when I'm adding these together, since I'm adding, the rule for adding and subtracting is my answer can only have the same number of decimal places as the least number of decimal places. Well, if I look at my original numbers, I keep in mind one of the things you could do is just underline the last significant digit in each one, and that'll remind me that I'm only allowed to count up to that digit as far as significant figures go. So when I'm looking at the number of decimal places for each answer, I'm only allowed to go up to the 2 here and the 1 here. So this has 2 decimal places, not 3, and this has 2 decimal places, not 3. So since the least number is 2, then that means I can only have 2 decimal places for my answer there, and so that means that my final answer is 63.55 AMUs for copper. And you'll see if you look on the periodic table, that is pretty much what you will have in the periodic table. So I hope this was helpful. This is a good example of a typical problem where you're asked to find the average atomic mass, and they give you the isotopes with their percent abundances and their masses. I hope you enjoyed this. Come back next time. If you like this video, share it, like it, write a comment in the comment section. If there's anything you want me to go over, click the bell so you can get notifications. Thanks for joining me, and I'll see you next time.